Hello everyone. A very good evening to each and everyone who are actually listening to me, viewing me. I mean to say, before I just say you anything, just actually give me the green signal whether I'm visible and audible to you or not. And then I'll actually talk about the same thing. Hello ones. Okay, hi dear ones. Good evening. Welcome to this particular session wherein today I am actually going to talk about the top 10 most important questions of biomolecules. So hi Tanu. Hello Shivam. Okay. Good evening dear ones. Hello Preetham. Good afternoon. I'm sorry, good evening. Okay. Yes, Tushar, absolutely right. So I believe that all of you are in your good health, safe at home, and yes, of course, preparing for your examinations. So hello Aakash, good evening. Welcome to the particular session. So today we are going to talk about biomolecules. So these are the top 10 most important questions, expected questions which you need to do. Okay? Hi Karthik, I'm good. What about you? Hello Rajput ji. Good evening. Yes. Chaliye dear ones, without any further delay to this particular session, let's begin our session. So, yes, good evening Satyajit. Hi Ahmed, good evening. Welcome to the class. Hi Vicky. Hello Sneha. Okay, good evening. So, let's start our session. Before I just go ahead, let me tell you one thing, that you need to actually hit the like button if you really think that this particular session is really wonderful and enchanting. Well, do subscribe the channel for your, I'll say, for your benefit only. Reason being, in the future there are many sessions which will be actually boosting up your preparations. So do subscribe the channel. Let's do one thing, share this particular session right at this particular moment among your friends. So Herin, wait a minute. I just need to have water. Okay, yeah, of course. Let's start the session now. So dear one, what actually now I want to say is, थोड़ा और एक दो चीज़ें discuss कर लेते हैं, and then we'll be actually talking about our main session. See, if I just talk about that, each and every one of you guys, obviously who are preparing for JEE examination, they want the personalized help, isn't it? Yes. So if you want the personalized help, what you actually have to do, there is a link given in the subscription box. Okay, I mean to say in the comment box, and there is a link given to you. Click on that link. Okay, download Aakash Byju's app, and yes, explore that particular app. Why? Because in that particular app you are actually going to have many things which will be useful for you. For example, there are video libraries, mock and previous year papers for you, skull crashers, that means very important questions, daily quizzes will be there, and yes, the most important thing is that your learning journey, fine, that will be analyzed. Fine, your weaknesses and strengths will be told to you so that you can outsmart your competitors, dear ones. Fine. So do not delay in this. Just go and download the Aakash Byju's app. Explore this particular app so that it will be really very much boosting up for your preparations regarding JEE examinations. So dear ones, this was all I want to talk about. Let's do it. Let's make it happen. Yes or not? Yes, of course, ma'am. So, hi, Meet. How are you? Hello, Nazim. Good evening. Hello, Abhishek. Good evening. Yes. Abhijit is saying, is it possible that from this particular chapter there will be questions in all shifts? Please tell ma'am. Yeah, there is a possibility. You can get at least one question. High possibility. Fine? Yes. So dear ones, let's start our session now with the very first question, and herein the question is in front of you. Out of the following, which type of interaction is responsible? Out of the following, which type of interaction is responsible for the stabilization of alpha helix structure of proteins? So I'm getting the regular answers, and the answers is actually right. I mean to say the answer which is actually being given by Aakash, Karthik, Preetham, Suman, okay, Yes, it's the hydrogen bonding. Shivam, the right answer. Absolutely right. It's the hydrogen bonding, the right answer for the question asked for. See, what basically happens if I just talk about the proteins. Initially, let's start me with the proteins. So, proteins are what? They are the polymers of alpha amino acids. Absolutely right. Yes, ma'am. And they are connected to each other by peptide bond. Peptide bond, or you can say peptide linkage. So peptide linkage is what? It's basically the amide formed between COOH group of one amino acid and NH2 group of the another amino acid. Yes, ma'am, that's absolutely right. Now what else? See, the secondary structure, if I just talk about of the protein, it basically refers to the shape. If I just talk about the secondary structure of the protein, it basically refers to the shape in which a long polypeptide chain can exist. बहुत बड़ी polypeptide chain exist करती है, ठीक है? So they are actually found to exist. These long polypeptide chains, basically they are found to exist in two different types of the structure. The one alpha helix, which we are actually talking about in this particular question, and the second one is the beta pleated sheets. The second one is the beta pleated sheet structure. Okay. Now what, ma'am? Now these structure arise due to what? These structures, I'm talking about the alpha helix and the beta pleated sheets. They basically arise due to the regular folding of the backbone of the polypeptide. Okay. Backbone of the polypeptide, regular folding of the backbone of the polypeptide chain. Why? Due to the hydrogen bonding between the C double bond O group of one amino acid, okay, and NH group, fine, of the peptide bond basically. Wait a minute, what I was saying कि जो alpha helix है और beta pleated sheets हैं, these structure they arise due to the regular folding of the backbone of the polypeptide. In polypeptide we do have the amide linkage, C double bond O NH basically. Fine. So there is actually hydrogen bonding between this C double bond O and NH group of the peptide bond. Clear? I'll show you now how. So alpha helix, if I just talk about, is one of the most common ways in which the polypeptide chains, they actually possibly form the hydrogen bond. How come? By twisting into the right-handed screw, you can say. Isn't it? Yes, ma'am. Wherein we do have that NH group of each amino acid residue hydrogen bonded to the C double bond O group of the adjacent alpha turn of the helix. I'll just show you how. So just have a look. It's just, I know you have given me the right answer, but I need to explain you. It's C double bond O NH over here. Then it's carbon, fine. Then C double bond O, okay. Then it's R, fine. Then moving ahead, and it's carbon over here, R over here. So in a way you are going to get like this. This is the way you are going to talk about. ठीक है, clear है? CR over here. Then if I move ahead, it's C double bond O, okay. Then it's NH, fine. Then it's C and it's R over here, okay. Then it's C double bond O, fine. It's N and it's H over here. Again the carbon over here. Then it's C double bond O over here. Then again if I just talk about N, and it's H over here, fine. Then it's carbon over here, R tending like this, okay. Then C double bond O, kind of like this. Now what? It's N, fine. Then it's H over here. So you can just have a look. See, it's the hydrogen and it's the oxygen. So there is the hydrogen bonding. Can you have a look like this? Yes, ma'am. So in this way, there is gonna be the hydrogen bonding between the C double bond O group and NH of the polypeptide. So you can just have a look. They are moving in which particular manner? Just have a look. So they are moving like this, 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 and this. And herein we'll be having the hydrogen bonding. Fine? Yes. Hello, Astha. No, you need not to memorize the whole structure. The answer you have given is the right answer, is the hydrogen bonding. No, not at all. Need not to remember the structure. Basically, I want to make you understand कि किस तरह से hydrogen bonding हो रही है in the alpha helix. That is what my point was. Hello, Harsh. Fine. Okay then, let's move ahead, and yes, most of you, I'll say all of you have given the right answer to the question, and it's option number B, the right answer, hydrogen bonding. Now talking about the second question over here. So dear ones, I believe all of you are in your activated state. Just do not lose your energy. So have water and be there with me. Fine. Yeah, of course. Yes, Asta, absolutely right. The question over here is, now over here, which particular question is, it's basically the glycosidic linkages they are actually want to ask us. Glycosidic linkages. So which glycosidic linkage between galactose and glucose is present in lactose? Okay. This is, see, each and every question over here is really the expected question to come, so you have to make a focus over here. So A for Agra, you have said, absolutely right, C1 of galactose and C4 of glucose. So which glycosidic linkage between galactose and glucose is present in lactose? For this you need to know the structure of lactose basically. Fine, and then only you can go ahead. So if I just talk about the lactose, which is basically formed, how it's actually formed, it's lactose is basically a disaccharide wherein we do have two monosaccharides units, beta D galactose and beta D glucose. Okay, fine. So yahan par if I just talk about the structure, just have a look. I'm going to talk about the structure over here, and it's H, fine. It's H, OH, okay. Then it's OH, H over here. Then over here it's H, OH, it's H and it's CH2OH. Fine, so over here I'm talking about beta D galactose. This is beta D galactose, okay, fine, and it's carbon number 1. Fine, so C1 and C4. Now over here you can just have a look. Wait a minute. It's kind of like this. Okay, ma'am. Yes, dear one. Like this, it's hydrogen over here, and you can just have a look. If I just talk about, okay, kind of like this, okay. So it's OH, fine, it's H, then it's H, OH, OH, H, and over here it's CH2OH and H over here. It is beta D glucose. It is beta D glucose. Wherein it's first, second, third and fourth. Okay, so you can just have a look. The glycosidic linkage is between carbon 1 of beta D galactose and carbon number 4 of beta D glucose. Okay, it will be the mixture. Astha, that will be the mixture. On the upcoming Sunday, we are going to have a chemistry marathon, and that will be the mixture. Fine, of physical, organic and inorganic chemistry. Okay, yes. So according to it, we can just say one thing. Yes, what is that one thing? It's option number A, C1 of galactose and C4 of glucose. So lactose is basically commonly known to be as milk sugar. Why? Because this is actually a disaccharide that is found in milk, and it is composed of beta D galactose and beta D glucose. Okay, so the linkage between carbon 1 of galactose and carbon 4 of glucose is basically known to be as the glycosidic linkage between galactose and glucose. Fine, absolutely right. Okay, done. Shall we move ahead? Any doubt for this particular question or something else you want to ask for regarding this question? Herein I am waiting for you. Manish, abhi sirf 2 questions हुए हैं. So this is the second question going on. I hope there won't be any doubt regarding this question. Okay, shall I move ahead? आगे बढ़े? Shall I move ahead? Say yes, ma'am. Done, and let's move ahead then. Okay, so let's move ahead. Okay, fine. Let's talk about the third question. Okay. Now, it's very easy peasy lemon squeezy question, but yes, such kind of question do come. Okay, so it's one of the expected question. Selivanov test and xanthoprotic test are used for identification of dash and dash respectively. Okay, just tell me. This is one of the question we did in the actually in the marathon series the last Sunday, the gone Sunday. And I believe all of you who have attended that particular marathon series, you might know and surely know the answer of this question. And you all are saying that it's option number C, ketosis and proteins. Yes, ketoses and proteins. Say, if I just talk about Selvinov test, basically, it's actually used to distinguish between ketoses and aldoses basically. So if I just talk about ketoses, for ketoses, the Selvinov test wherein the reagent is resorcinol and dilute HCl. Okay, we are going to get a red cherry color. Okay, cherry red color we are going to get if we are talking about ketoses for Selvinov test. That is the positive test for ketoses. Wherein if I just talk about aldoses, faint pink color or red color we are going to get for aldoses. Okay, that's absolutely clear. Just let me know. Yes, so for Selvinov test, we'll be actually saying it's the test used for identification of ketoses. Shivam, Asta, Suman, Yash, Mr. Nobody, Karthik, Vicky. Thank you so much, Vicky. Thank you so much. Okay, you know what? Such type of compliments actually motivate us, okay, the teachers. Okay, fine. Okay, good Asta then. So it's the ketoses we are doing. Okay, so if that's the ketoses, so B and D options are out. But if I talk about the xanthoprotic test, so it's basically the test wherein we actually detect what the presence of aromatic amino acid. For example, tyrosine and tryptophan. Okay, for example, tyrosine and tryptophan. Is the thing clear to you? If I just talk about tyrosine, okay, fine, clear. So wait a minute, tyrosine and tryptophan, what are they? They are aromatic amino acids. The structure of them, if I just talk about, it's the NH2, then it's carbon, hydrogen, then it's COOH, okay, then it's CH2, then this is the ring we do have, and this is OH. So this is our tyrosine. This is what? The tyrosine. In case if I just talk about tryptophan, so tryptophan, it actually looks like this. Okay, and it's CH2 over here. Fine, it's the carbon over here. It's a hydrogen, C double bond OH, and it's NH2. Fine, so this is tryptophan. Okay, I just request you, and it's an advice that you need to actually learn the structure of at least 20 amino acids. Do that. Fine? Okay. Yes, of course. Of course. So over here, obviously, it's option number C, the right answer, ketoses and proteins. Fine? Okay, done. Shall we move ahead? Aage badhe. So what happens in xanthoprotic test that suppose if we are taking 2 ml of a protein, we'll add 1 ml of concentrated HNO3 to it. We'll heat for about 2 minutes and then we'll cool it under a tap water. Afterwards, what we are going to observe is a yellow color is obtained due to the nitration of the aromatic compound, aromatic ring basically. So afterwards, if we add to that yellow color thing, the nitrated product which we have got, if we add few drops of 40% weight by volume NaOH solution, the yellow color which has been obtained initially changes to orange. So basically it actually tells us about the presence of aromatic amino acid. Yes, कार्तिक ने बिल्कुल सही कहा. At least one question आप expect कर सकते हैं. So इसको हल्के में मत लीजिएगा. Direct question आते हैं. ठीक है, कभी कभार जो क्वेश्चंस आते हैं बहुत इजी होते हैं. So go ahead with it. Fine. So moving ahead and let's talk about the next question. I believe इस question का आंसर मैं already दे चुकी हूँ. Now your turn to tell me the right answer. Which of the following is the correct structure of tyrosine? Correct structure क्या है tyrosine का? Just let me know. Correct structure बताइएगा आप मुझे. Yes. या मिस्टर नोबडी ने बिल्कुल सही कहा कि येलो कलर जो होता है इट कंफर्म्स द प्रेजेंस ऑफ एरोमेटिक अमीनो एसिड. यस ऑफ कोर्स, एब्सोल्युटली. हाँ जी. ओके, so over here it's option number C. Nobody says it's option number C. Manish says it's option number C. Actual में मैं इसका आंसर already कर चुकी हूँ. अभी previous slide में मैंने इसका आंसर बताया आप लोगों को. So I hope you all will be giving me the right answer to the question. Sumit says option number C. Anurag says option number C. Aakash says option number C. Yes, dear ones. Mr. Yashir says option number C. Rohit says it's option number C. Karthik says option number C. So yes, everyone, it's option number C only. Okay, so what we can say to it as a para-hydroxy phenylalanine. What basically tyrosine is, it's a non-essential amino acid. The body makes from another amino acids called phenylalanine. Fine. So it is essential component for the, if I just talk about phenylalanine, so it's basically the essential component, or you can say about the tyrosine itself, it's basically the essential component for the production of several important brain chemicals known to be as neurotransmitters, including dopamine, I can just say, okay, if I just talk about norepinephrine, okay, fine, and it's also epinephrine, yeah, these are the neurotransmitters. So if I just talk about the phenylalanine, or you can just say about the tyrosine, it's the essential component for the production of what? Several important brain chemicals known to be as neurotransmitters. Fine. So tyrosine is basically what? Tyrosine is basically para-hydroxy phenylalanine. That's what I want to talk about. Is it actually clear? So over here option number C is the right answer. Moving ahead, and let's talk about question number 5, dear ones. Acha, koi doubt ho to you can just ask me. Any doubt? Anurag, Aakash, Karthik, Yasir, Rohit, Sumit, Astha, and whosoever is actually watching this particular session, Mohit. Mohit ne iska answer bata diya. You've just told me the answer of this question. A non-reducing sugar A hydrolyzes to give to reducing monosaccharide. The sugar A is actually this question ke andar I'll just say one thing, that there is only one option which is a disaccharide, and you know what, elimination method से we can actually reach to it. अगर आपको पता है कि monosaccharide and disaccharide क्या है, you can easily go ahead with this particular question. ज़्यादा सोचने विचारने की ज़रूरत नहीं होगी आपको. Okay, so if I just talk about reducing sugars, are those sugars which do have a free anomeric OH group basically. Okay, and a non-reducing sugar is the one which do not have a free anomeric carbon atom, or you can say free anomeric OH group basically. So that is what I want to talk about. And it's, if I just talk about sucrose, it is a disaccharide of alpha D glucose and beta D fructose. Alpha D glucose and beta D fructose. So if I just talk about sucrose, it's a disaccharide of two monosaccharides. It's alpha D glucose and beta D fructose. Fine. Okay, so sucrose is basically a non-reducing sugar. Okay, clear? Anyone, any doubt? किसी को और कुछ पूछना है इसके अंदर? Do you want to know about the structure of sucrose? Anyone, or shall I move ahead? Because I believe कि alpha D glucose और beta D fructose को when we actually condense them out, we actually get sucrose, और sucrose को जब hydrolyze करेंगे तो we are going to get the same. No ma'am, no issues? चलिए, just let me know. Yeah, crystal clear. HDCC, high definition crystal clear. चलिए आगे बढ़ते हैं without any delays, and here we are on question number 6. Over here we are on question number 6, wherein the question have asked you, see इसकी एक टेबल दी हुई है NCERT में, so please go thorough with that particular table because generally question पूछे जाते हैं. ठीक है? Okay, so go thorough with that particular table. NCERT में table दिया हुआ है. So it's a thiamine and pyridoxine. They are respectively also known to be as, you all are saying vitamin B1 and vitamin B6. Wow, absolutely good dear ones. बिल्कुल सही बोला आपने. अच्छा, thiamine के बारे में अगर मैं कुछ बोलना चाहूँ, it's basically the pyrimidine base. It's basically the pyrimidine base. और जो base होते हैं, if I just talk about the bases, they are the components of nucleic acids. Nucleic acids का मतलब polymers whose monomer is actually what? The nucleotide. तो न्यूक्लियोटाइड के अंदर we do have base, sugar and phosphate. Okay, clear है ये वाली चीज? तो यहाँ thiamine जो है, it is a pyrimidine base. We have two type of bases, pyrimidine bases and purine bases. Thiamine हमारा pyrimidine base है. And if I just talk about the structure of thiamine, the structure of thiamine is a C double bond O. It's nitrogen, it's hydrogen over here, it's over here, and it's NH. then double bond over here and CH3 over here. So this is thiamine. Okay, and commonly we say vitamin B1 for thiamine. Vitamin B1 for thiamine. Okay, what are the sources of thiamine if we want to have it? So it's yeast, milk, green vegetables, cereals basically. And what will be the deficiency caused? If I just talk about that, if we don't have vitamin B1 or thiamine in our body, then what is the deficiency then? We will be actually having beriberi diseases. Yes, yes, of course. Wherein if I just talk about pyridoxine, if I just talk about pyridoxine, and the structure of pyridoxine is it's CH2OH, okay, and this it's OH over here, then it's Me over here, then double bond, okay, double bond N, and herein what you can just go ahead with it, CH2OH, fine. This is basically commonly known to be as vitamin B6, vitamin B6. And what are the sources basically for vitamin B6? Again, yeast, milk, egg yolk, cereals, grams, etc. Basically this pyridoxine, if I just talk about, it's found in food and it's used as a dietary supplement. Okay, clear है ये वाली चीज? कोई doubt नहीं होना चाहिए, because easily I have actually talked about. Now what will be the deficiency caused? What will be the deficiency caused? Yeah, if we have actually deficiency of B6, okay, then the disease which we are going to have is basically you can say microcystic anemia and skin rashes, okay, and also it results in weakening of the immune system. That's what I want to talk about. High definition, crystal clear? Okay, shall we move ahead? So it's option number C, the right answer, vitamin B1 and vitamin B6. Moving ahead, and let's talk about the next question. It's very easy peasy lemon squeezy question. आपको बताना है, fructose is the example of what? Good afternoon, Mr. Gamer. So fructose, Ayush, you need to study biomolecules. It's a really I'll say a request and an advice to you, because see, direct questions do come and it's a very scoring chapter, so don't miss this particular chapter. Okay, yes, so fructose is basically what? Yeah, all of you are actually giving me the right answer. Fructose की अगर बात करें, it is an example of ketohexose. Ketohexose. So अगर मैं fructose का structure बनाऊँ, it's CH2OH, C double bond O, then it will be OH, H, OHH, H, OH, then it's H, OH, and it's CH2OH, okay. So fructose is an example of ketohexose. Ketohexose की बात कर रहे हैं हम यहाँ पर. Okay, well if I just talk about aldohexose, aldohexose is known to be, अगर मैं aldohexose का कोई example की बात करती हूँ, if I just talk about the example for aldohexose, I'll straight away say it's the glucose. Okay, talking about ketopentose. Okay, let's talk about ketopentose. Example देखें ketopentose का. Yes ma'am, ketopentose का example देखना जरूर चाहेंगे. So ketopentose का example, it's CH2OH, then it's C double bond O, then it's HOH, okay, and it's HOH and CH2OH. So what should we say to it? It is known to be as D-ribulose. D-ribulose. Is the thing clear to you? Yes ma'am. अगर मैं बात करती हूँ एल्डोपेंटोज के एग्जाम्पल के बारे में, एल्डोपेंटोज का एग्जाम्पल के बारे में अगर मैं बात करूँ, so it's CHO, then you can have HOH, 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 and it is CH2OH. Fine. So you can just write it as D-ribose. You can just talk it about as D-ribose. So मैंने आपको examples दे दिए हैं इन सब चीज़ों के. Yeah, of course, nobody. आप बिल्कुल सही कह रहे हैं. It actually exists in a fructofuranous structure. इसका structure जो है cyclic ring structure है, and absolutely you are right over here. So fructose is basically the example of ketohexose. ये मैं आपको यहाँ पर clear करवाना चाहती थी. Done, done, done. Yes, ma'am. Absolutely done. Go ahead with the next question. Herein we will be talking about the next question, and you have to tell me the water soluble protein is. देखिए as it is, ये question NCERT में से लिया हुआ है. तो ऐसा ही होगा जेई मेंस के अंदर एज इट इज फॉर बायोमोलिक्यूल्स। आई एम जस्ट सेइंग एंड फॉर द चैप्टर्स लाइक केमिस्ट्री इन एवरीडे लाइफ आपको स्ट्रेट अवे एनसीईआरटी में से क्वेश्चंस मिलेंगे। सो फॉर बायोमोलिक्यूल्स, फॉर केमिस्ट्री इन एवरीडे लाइफ, गो थॉरो विद द एनसीईआरटी थिंग्स। ओके, वेल ऑल ऑफ यू आर सेइंग द राइट आंसर। एल्बुमिन इज अ वाटर सॉल्युबल प्रोटीन। एल्बुमिन क्या है? वाटर सॉल्युबल प्रोटीन है। अगर मैं प्रोटीन की कैटेगराइज करूं प्रोटीन को, सो वी टॉक अबाउट द फाइब्रस प्रोटीन एंड वी ऑल्सो टॉक अबाउट द ग्लोबुलर प्रोटीन। अब जो फाइब्रस प्रोटीन होता है इट इज इनसॉल्युबल इन वाटर, ठीक है, इट इज बेसिकली इनसॉल्युबल इन वाटर होता है। फॉर एग्जाम्पल अगर मैं बात करती हूँ फाइब्रस प्रोटीन्स की, लाइक केराटिन की अगर मैं बात करूं, मायोसिन की अगर मैं बात करूं, ये जो मायोसिन है इट इज इनसॉल्युबल प्रोटीन, इट्स बेसिकली द फाइब्रस प्रोटीन। ये मायोसिन कहाँ प्रेजेंट होता है? इट इज प्रेजेंट इन मसल्स बेसिकली। ओके, अगर मैं बात करती हूँ कोलेजन मॉलिक्यूल के बारे में, इस कोलेजन के बारे में बात करूं, सो आई विल से इट्स द मोस्ट अबंडेंट प्रोटीन इन ह्यूमन बॉडी। ठीक है, ये मोस्ट अबंडेंट प्रोटीन है ह्यूमन बॉडी में। इट्स बेसिकली अ लॉन्ग रिजिड स्ट्रक्चर जहां पर यू आर गोइंग टू सी 3 पॉलीपेप्टाइड्स, दे आर एक्चुअली यू कैन से वाउंड अराउंड each other. They are actually wound around each other, okay, in a rope-like manner, like a triple helix you are going to get for collagen. Okay, so this collagen, if I just talk about, again, it's a most abundant protein. Fine, if I just talk about collagen. Talking about fibrin, okay, and over here, if I just talk about fibrin, okay, पहले हमने एल्बुमिन की जो हमने ऑप्शन नंबर ए की जो बात की, यस इट्स एब्सोल्युटली राइट। या ऑफ कोर्स हर्ष थोड़ा कुछ तो मुझे यहाँ बताने दो इसके बारे में। एल्बुमिन के बारे में मैंने आपको बता दिया, इट्स बेसिकली अ ग्लोबुलर प्रोटीन एंड दिस स्ट्रक्चर, ग्लोबुलर प्रोटीन के बारे में अगर मैं बात करना चाहूँ, दिस स्ट्रक्चर रिजल्ट्स कब? व्हेन द चेन्स ऑफ पॉलीपेप्टाइड दे एक्चुअली coil around to give us spherical shape. Okay, usually they are soluble in water. For example, insulin and albumins, they are actually the examples of it. और albumin कहाँ present होता है? Blood plasma में present रहता है ये, ठीक है? Yes, absolutely right. फाइब्रिन जो है, yes तुषार, फाइब्रिन के बारे में मैं कहना चाहती थी। फाइब्रिन जो है ये एक इनसॉल्युबल प्रोटीन है और ये कब प्रोड्यूस होता है? इट इज बेसिकली प्रोड्यूस इन रिस्पॉन्स टू ब्लीडिंग। Okay, and it's basically the major component of the blood clot. It's basically the major component of the blood clot. बिल्कुल तुषार, आपने बिल्कुल सही बात की। So we talked about albumin, we talked about collagen, we talked about myosin, we talked about fibrin. तो एक तरह से अगर देखा जाए तो myosin, fibrin, collagen, they are insoluble proteins, wherein albumin जो है वो water soluble globular protein है हमारा। Okay? तो ऑप्शन नंबर ए सभी ने बिल्कुल सही बोला है, एब्सोल्युटली राइट। ठीक है, आगे बढ़े। यस, हेरेन विल बी नाउ टॉकिंग अबाउट क्वेश्चन नंबर 9। ये हमारा क्वेश्चन नंबर 9 है, द सेकेंड लास्ट क्वेश्चन ऑफ द सेशन। बहुत इजीली एंड जल्दी वी हैव फिनिश्ड आवर सेशन। यस यस मैम। तो ओवर है, विच वन ऑफ द फॉलोइंग इज द करेक्ट स्ट्रक्चर ऑफ साइटोसिन? साइटोसिन का करेक्ट स्ट्रक्चर। अब साइटोसिन क्या होता है? इट इज अ पिरामिडिन बेस। It is a pyrimidine base. अगर मैं कहूँ, we do have 3 types of pyrimidine bases. It's the thiamine, it's the cytosine, and it's basically the uracil. Okay. Well, all of you are actually saying कि मैम जो cytosine है, yeah, Smriti, what you want to say? See, if I just talk about cytosine, it is a pyrimidine base. We do have 3 types of pyrimidine bases: thiamine, okay, cytosine, okay, and uracil. फाइन, क्लियर है ये वाली चीज आपको? यस मैम। तो साइटोसिन का एक तरह से स्ट्रक्चर तो जो देखा गया है, इट्स ऑप्शन नंबर ए। ठीक है, साइटोसिन का स्ट्रक्चर इज इट्स NH2 ओवर हेयर, क्लियर है ये वाली चीज, देन डबल बॉन्ड N, देन डबल बॉन्ड O, देन NH ओवर हेयर and it's kind of like this. This is our cytosine. अगर मैं बात करूं यूरेसिल की, यूरेसिल के स्ट्रक्चर के बारे में भी बात कर ली जाए तो इट्स डबल बॉन्ड O, इट्स NH, देन इट्स डबल बॉन्ड O, देन यहाँ देखिए इट्स NH एंड दिस इज यूरेसिल। ओके, और अगर बात की जाए किसके बारे में? थाइमीन के बारे में, जिसका हम एक्चुअल में पहले भी अभी पढ़ के आ चुके हैं। सो इट्स डबल बॉन्ड O, इट्स NH, डबल बॉन्ड O, NH and it's Me over here. Yes, absolutely right. प्रीतम ने बिल्कुल सही बोला कि DNA contains cytosine and RNA contains uracil. बिल्कुल सही बोला. DNA में what type of bases we do have? Adenine, purine base है, thymine, pyrimidine base है, guanine, वो प्यूरिन बेस है, साइटोसिन pyrimidine बेस है. और अगर मैं आरएनए की बात करूं, विच टाइप ऑफ बेसिस डू वी हैव इन आरएनए? इट्स एडेनिन, यूरेसिल, गुआनिन एंड साइटोसिन. ठीक है, ओके, डन 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 डन. तो यहां पर जो हमारा आंसर सही है, इट्स ऑप्शन नंबर ए, रेस्ट अदर आर नॉट. ओके Okay, Astha. Ma'am, do take one session completely based on practical organic chemistry before first attempt. Okay. चलिए, let's move ahead. इसमें कोई doubt? I don't think इसमें कोई doubt होनी चाहिए. चलिए चलिए. And herein we'll talk about the last question of the session. The compound A is complementary base of dash in DNA. अब ये क्या है? What do we have over here? This is what? Can you just tell me? ये एक्चुअल में क्या है? इट इज थायमीन. दिस इज थायमीन स्ट्रक्चर. यस, सो थायमीन का कॉम्प्लीमेंट्री बेस क्या होगा डीएनए की स्ट्रैंड में? वी हैव AT एंड CG. ये है हमारे पास. अगर वी डू हैव एडेनिन, ठीक है, अगर एडेनिन है तो थायमीन होगा, अगर साइटोसिन है तो ग्वेनिन होगा. तो ये हमारा थायमीन है, तो ऑब्वियस सी बात है इसका कॉम्प्लीमेंट्री बेस होगा एडेनिन. इसका कॉम्प्लीमेंट्री बेस होगा एडेनिन. एडेनिन का स्ट्रक्चर क्या होता है, कैसा होता है, कैसा दिखता है एडेनिन? ये देख लीजिए, यहां पर मैं बता देती हूँ एडेनिन का आपको स्ट्रक्चर भी. एडेनिन का स्ट्रक्चर, सो दिस इज आवर एडेनिन. ये है हमारा एडेनिन. ओके, एडेनिन. फाइन, डन डन डन. तो दिस वाज द एंड टू आवर this particular session of percentile booster, wherein we have actually completed top 10 most expected questions from biomolecules. Well, dear ones, I rest my case for this particular session here only, and the upcoming session is basically of again the percentile booster mathematics, that too at 6:30 PM, so don't miss that particular session. Fine, okay, clear है? हाँ जी. Oh, isn't? Thank you so much. Thank you so much, Ashta. Okay, fine. So this was all about the session. Thank you so much, guys, for cooperating with me. And yes, we'll be meeting soon again. So do not miss the session. Subscribe the channel for the further notification. Till then, goodbye. And yes, be in your good health.